Hello, this is Edward Doolittle back with another installment of Math 101. In this short lecture, I'm going to talk about the division of rational numbers. So already we've talked about addition, subtraction, and multiplication of rational numbers, not necessarily in that order. We learned about multiplication first because it was easiest, and then addition and subtraction. Now we're going to learn about division of rational numbers. We are going to see that it's actually not so hard, but maybe it's conceptually a little harder than some of the other operations. I put it after addition in our sequence because the way I'm going to approach division is similar to the way I approach addition. And that is, the key idea here is a common denominator. All right, so let's take our old friends here, 2/3 and 1/4, and I want to divide them. And now let's ask a similar question, of course a little different, but similar. What if I had 2 yards and I wanted to divide it by 3 feet? So a yard is itself 3 feet in size. So 2 yards is 6 feet. I divide it by 3 feet. I should get the answer two times. So this 3-foot measure goes twice into 2 yards. And so that's just, reasoning, knowing what we know about the units and the sizes. The picture looks something like this. Here is 2 yards. Here is 3 feet. The question I'm asking is, how many times does this 3-foot measure go into 2 yards? And the answer is, well, it goes in exactly twice. So the answer to this question is 2. But that's not apparent just looking at the numbers. So 2 divided by 3 is not the same as 2. 2/3 is less than 1, and it's very different from 2. So I can't just divide the numbers. This is very similar to when I was talking about adding. Say if I added 2 yards and 3 feet. The key here is to convert to the same unit. So I need to convert yards into feet, and 6 feet. So 2 yards is really 6 feet. And I divide that by 3 feet. And I'm going to get the correct answer of 2 if I just divide the numbers. Right, so back to our fraction, the thing is we've got units in these fractions. The units are the measuring stick, and in this case, they're different for the 2 fractions. So I can't just divide 2 by 1 to get the answer of 2. That's not correct. I have to take into account these units, and I do that by converting to the same units for both fractions. And if you recall, the correct one way to do this anyway is 12ths. So 2/3 is 8/12. And 1/4 is 3/12. And now that the units are the same, I'm going to put units in quotes because it's not exactly like units, but 12ths is a unit almost. Anyway, units are the same. So we can disregard them. So that becomes 8 divided by 3, which is written as a fraction as 8/3. Right, and that is the correct answer to this question, 8/3. All right, so that is the idea of how we're going to divide fractions. Let's take another example. Okay, just a couple of fractions I just kind of picked out of thin air here, cooked up in my head. We have 4/5 and we're dividing by 2/35. I have to find common units. In this case, it's easy. The common units is going to be 35ths. I don't have to change the second fraction. The first fraction, what did I do? I multiplied 5 times 7 to get 35. So I'm going to multiply 4 times 7 to get 28. And then now we are measuring in the same units, so 28 divided by 2. And I know that's 14. I don't even have to write it as a fraction, though if I really wanted to write it as a fraction, I would write it like that. Right, so that's just another example I just picked out of thin air, and now you can do any fraction that way. The key is to find a common denominator. And that is all there is to dividing fractions. You can make it more complicated. I choose not to. Some people talk about quote-unquote inverted multiply. I'm not going to even write that down because it's kind of frightening to a lot of people. It's an arbitrary seeming rule that doesn't necessarily make sense. So I'm just going to let's just forget that whole thing. You can certainly use it if you know about it. If you're adept at manipulating fractions, you can do these fraction arithmetic in any way you wish, as long as you get the correct answer. But this is the way I suggest it, the common denominator method, because it leverages our existing knowledge. We don't have to learn any new techniques. We know the common denominator method already from addition and subtraction of fractions. We spent a long time talking about it, so I'm not even going to go into detail about how to do it. Let's maybe do one more example here. So let's take 7/8, and I'm going to divide by 11/12. Okay, so in this case, I want the common denominator of 8 and 12. And we know that that is the LCM of 8 and 12. And the LCM of 8 and 12 is 8 times 12 divided by the GCD of 8 and 12. And GCD of 8 and 12, let's work that out. I know what the answer is already because we've done this one before, but let's go through some steps. This is the same as the GCD of 8 and 4, and that's the GCD of 0 and 4 by division, and that is 4. So this answer is 8 times 12 divided by 4, and so the answer is 24. So that is my common denominator. I need to make this a fraction out of 24, and I need to make the next one a fraction out of 24. What did I do here? I multiplied by 3, so that's what I have to do here. Multiply by 3, I'm going to get 21. What did I do here? I multiplied by 2, so that's what I have to do here. Multiply by 2, I got to get 22. And so final answer, well, this is the same as 21 divided by 22, which is just 21 over 22. Okay, so that's the final answer to our division question. And all there is to it is common denominator method that we know already. So we're just leveraging our prior knowledge about fraction arithmetic to help us do division. All right, so there are other ways, like I said, but you go ahead and use them. I'm not going to teach them. This is all we need to know about fraction arithmetic. We've done all the important things. We've done plus, minus, multiplication, and division of fractions. There's two other things, and I'm not going to do them, but I just want to draw your attention. There's GCD of two fractions and LCM of two fractions. It is possible to do the GCD and the LCM of fractions. Strangely enough, I looked at an old-time arithmetic textbook from the 1880s, and sure enough, they did this sort of thing. They did the GCD and the LCM of fractions. So students back then were learning this material, and I don't know what's happened since then, but we stopped teaching it, so I'm not going to bother teaching you the GCD and LCM of fractions. Anyway, it's a nice puzzle if you want to try to sort it out yourself, but it's not going to be on our exam. All right, so that is it for for fraction arithmetic. We will now finish off this section in another lecture on the irrational numbers, numbers which are not rational. And it may come as a surprise to you, but there are numbers that cannot be represented as fractions. And we'll talk a little bit about that in our next lecture. All right, thanks, bye.